72, 100. Anyone? Save me doing it. 28 and 16, 42, 140, 144. Okay, this one should be easier. Should be easier. Should be 96. Okay. So we're at a stage here where we don't have a constant third difference. So we'd scrap our linear, quadratic, and cubic ideas and formulas, and we have to come up with a different one. So this is a geometric or exponential. As in, it's there, at no stage is the growth constant. There's a way you can actually do this with calculus and look at the rate of change of the thing, of the sequence. And the rate of change of this is actually always changing as well. So it's getting exponentially bigger each time. So these numbers, actually the first difference is 8, then 16, then 32. You know the first difference is the next one, maybe you can see that pattern. What do you think the first difference is, or the fourth difference would be here? 64. Do you think that has any relation to anything?
Yeah, 32 times 2.
Yeah, they double every 2.
Yeah, you're times in 2, yeah. Okay, will that have any impact on our formula? I think we can create a general formula here. You figured out the sum times in by 2.
Well, the first one you times by 8, second you times by 4, 30 times by 2. So you have the multiplication.
Okay, so what you do look for here is instead we kind of scrap this addition thing and we look for some multiplication. And if I know 4 has become 12 through some yeah. So we're multiplying by 3. Where did I get 4 and 12 from? Well, 4 becomes 12. And then 12 becomes 36 through some multiplication. It is also 3. How do you do that systematically then instead of writing out something like this? Is there a quicker way of doing it using division? Well, division is the opposite to multiplication. So if I divide 36 by 12, I get 3. If I divide 12 by 4, I get 3. So whichever way you want to figure it out, but I know I am increasing by 3 each time. So if I want to find, so this is the first term, the second term, third term, fourth term, fifth term. If I want to find the 10th term, so I skip a bit, I want to find the 10th term, how would I find that? Well, let's work off the first term. So if I had 4 and I want to find the 10th term, what would I multiply it by? Definitely going to have to multiply it by 3 once. How many times am I going to end up multiplying it by 3? 10 times. 10 times? Remember, to get the second term, I'd multiply by 3 once. So I'd have to multiply it by 9 times. Now, obviously, there's a quicker way. 1, 2, I've lost count. 3. There's a quicker way of doing this, isn't there? 3, yeah. Power of, yeah. So 4 by 3 to the power of 9 will get me to that will get me the 10th term of this one. Now, in general, how would I get the formula? Like, if I didn't want to find the 10th term, I wanted to find the nth term of this sequence. So any term. So what's the relationship between 10 here and this 9 here?
It's n minus 1.
Yeah, it's 1 less, isn't it? It's always going to be 1 less. So if we want the 4th term, we end up multiplying by 3 only 3 times. So it's 1 less. So the general term here is 4 by 3 to the power of n minus 1. 1 less than the term we're looking for. So in general, what is this formula? The nth term of a geometric What could I say? First term multiplied by, okay, common ratio. So we need a word for this, the multiplier or whatever it's called. It's called a ratio, yes. So we use difference over here for when we're adding, subtracting. Ratios when we're multiplying or dividing.
Is
So
it supposed to be multiplied to ratio?
yes. But what happens if it's something like this?
Multiplied by 0.2.
It's dividing, but we want to write it as a ratio. So you can write dividing as a ratio. How do we write it? Multiplying.
Multiplied by 0.
1/2.
If you multiply by 1/2.
0.5.
Yeah, okay.
We prefer the fraction because the fraction works better with indices because I can change that to 2 to the power of -1 if I want. And then if I have an n minus 1, I can apply that. So I prefer that than the decimal. Okay, so yeah, you're right. It's the ratio, the OR value, which is this, that's OR, to the power of n minus 1 always. And that's the nth term. So there's other ways of writing this. Some people use the letter A for the first term or U1 for the first term.
What's R for?
Ratio.
Okay, so OR is this thing you're multiplying by. So in this one, that is OR. In this one, that is OR.
How do you write it like the actual way, like not first term?
You don't like this way?